coordination of distributed software with Redis. It's this time more on the application level, after we have seen two interesting talks more about the tooling level. So first I go to introduce you to how we work and what we wanted to achieve. Then I will explain why we choose Redis and how does Redis work. And finally, you get some hopefully interesting implementation details. Okay, Open Systems is a managed IT security providers. We operate about 4,400 hosts in 180 countries. So we now look a bit more close at how we do change management. Say hi to Alice. She got the task to change firewall rule for her customer. So she changes the firewall rule in our portal, and then she needs to roll it out. To do so, she logs into the Bastion host and then runs a tool which creates the configuration, uploads it on the host, and applies it there. And now she needs to do this 50 times, as her customer has about 50 locations. Now I would like to introduce you to Bob. To what is he up today? He wants now to bring all the hosts to the latest level of the operating system, which is a custom Linux. So first he wants to do the early adopter host, later all the rest, and ideally the patch is rolled out at local nighttime. So what we want now is to support these use cases with a job scheduling system. Besides scheduling, there are a few more requirements. As we already have seen several types of jobs, there should be some kind of grouping, because we want to run these jobs for a list of selected hosts. Then they should run on several worker hosts, like this Bastion host, so that we achieve on one side better availability if one goes down, and horizontal scaling. And finally, we want to have a command line interface, and also the web portal should be able to show what's going on in our job scheduling system. Okay, let's look now at the data model. We have a user which places orders in the system, which we call job groups, because it contains a number of jobs, one per host. Next, we need a job queue, which then shows us where and when exactly the jobs should run. And finally, we want to know what happens to the job, so we need some kind of log. So, with the task ready, I need some kind of coordination, or a shared data store. And I was told, check out Redis. Okay, what is Redis? It's a key value database. As a Perl programmer, I think it must be kind of a remote hash. Let's check out if that's correct. I go to the Redis homepage. It looks like this, a lot of text. It's kind of database. Okay, I need that. It supports strings, hashes, lists. As the Perl programmer, I'm used to that. Sets and sorted sets, they might be useful as well. I guess it's more like a global variable store, which is a global store where different nodes and processes can have like a central variable store. Sounds useful. What's also nice, you can give the keys and the data an expiration time, and at that moment it will disappear out of the system. It is an in-memory database, plus it runs, the server is just one single thread for all its clients, which is okay for our job scheduling system, but if you want to do some heavy lifting, it's probably not the best. And how do we work with Redis? Here, there are a list of commands. There are about 200 of them, different complexity. We look now at the simple one. This is the example section of the documentation of the get command. It's the command line interface, which is very simple. First, you get the command, you get the key, and whatever other arguments will come after. Okay, first we get something which is not yet set there. We get nil. We set some value. We get an OK back. We get it, try to get it out again. Here it is. All very simple. The neat thing about these examples on the Redis documentation homepage is that it's actually, they're really executed, they're really backed by Redis server. So you can just simply on the web page try it out without the need to have a local installation. So now I want to make this key disappear in 5 seconds. Now I hit enter. Okay. Still there. Wait a bit more. Now it's gone. Now, how do I use that in Perl? Again, it's rather simple. Get Redis from cpan. Then it has a new construction which allows it to connect to the Redis server, and then you have a Redis connection object. Then you can use, then you have for each command, you have a method where you can give the key and any arguments, and so here you get the same example as we have seen before. Now we have all ready, so we can go to the implementation. Just as a reminder, this is the objects which we want to have in Redis. So first I need kind of a possibility to identify the objects. Some kind of atomic global counter would be nice. Redis helps me here with the include command, which just adds one to a variable which is stored on the Redis server. And if I do it the second time, I get 2, so I can have more than one user adding jobs at the same time, and they don't disturb each other. And already is copied as auto vivification from Perl, so when there is no variable yet, it will just create it. Whatever command you use, if there is nothing, it will just create the suitable object. So I have now here the 3 counters for each object type. As you see here, it's rather common in the Redis world that you separate the key, the different elements of a key name by a column. Next, I need the object data. As a Perl programmer, I take a hash, which is also supported by Redis. As you see here in the example here, the Redis commands for hashes are prefixed by h. First, I have HMSet, hash multiple set, where I set 2 values, then an ID and the user, to the hash job group column 2. Here I just get the user out of it, and if h get all, I get all data. And as you see here, the return values are like a Perl hash in this context. Okay, here I have the object data with data type colon ID of the object, and now I need to put them together. Like I need to connect the job group to the jobs, so I need collections. There are a few options. If uniqueness is important, we use sets. If you put more emphasis on the order, then you take list. And if you want both, you use sorted sets. So what I have here is a set for all job groups, a set for jobs inside of a job group, and a list for the log events. And I will make all of them, or most of them, expire after 30 days after they have been used last, except for the counters and like the global group of all job groups which are available. So one thing is missing, the job queue. Here I can use a sorted set from Redis. As we see here, the set is used to prefix all the commands for sorted sets. Here I add the first job into a job queue, which is supposed to be run at the time 120. Then I add a second job at time 60, and now I'm at time 100. And I want to know what should I do now. So I use set range by score on the job queue from the beginning of the time until now, and so I have the job which I can now run. Timeout. I cannot run it now because remember it's a distributed system, so there might be some other worker element which tries to do the same at the same time. So I need to somehow lock the job. In Redis, we usually do a job lock by setting a variable and check, and there is this nice annex feature, which is a flag to the set command, which only stores the value if the key does not exist yet. So the first one gets an OK, so he has the lock. The second one fails, so the client knows that he did not get the lock. And after you're done, you simply delete the lock, and then someone else is allowed to set it again. A more advanced version of a Redis lock works with a timeout. You maybe don't know if the worker crashes somewhere in between, so you have another argument to the set command, which is X for expiry, which allows you to set an expiration period to the value. Again, the second one cannot lock it, and after 1 hour the lock would automatically be deleted, so some worker could come and just do the job if it didn't run, or just remove it with an error from the job queue if something is strange with the job. The unlock is a bit more difficult here. You could simply delete it, but then you might delete it after the timeout, so which would cause you to delete the lock of someone else maybe. And so you should actually save there in the value a unique nonce, so that you can come back later and check it's still my lock, and if it's my lock, I delete it. Still, there may be a small window for race condition between checking the value of the lock and deleting it, because in between the job could run out and someone else could set the lock again. So to do that, there is a feature on Redis. You can have server-side Lua code running, and you have to do a small program which just does the check and deletes the key if the check is successful, and it's all documented in the documentation of the set command on the Redis homepage, how this has to be done. Okay, we have now already how we want to do our data model, how we want to do it in Redis. So I will now present you the kind of hard procedure of this job scheduling system, which gets you a job from the job queue, which is now ready to run on the worker level. So I get the Redis connection, I get the jobs which are ready to run, and I look through them to check if I can get one for me to work upon. So first I log the job. I like to have some kind of value which also explains who is holding the log. It helps for debugging. Then I have to make sure that the log is still in the job queue, that it's still valid to execute the job, because the world might have changed in between looking up the job queue and logging. So I just get with the set score command, I get the current scheduled time from the job queue. If it's still in the job queue, I'm okay. If it's still supposed to run, I'm okay. Else I will just delete the log and try the next. And if I'm supposed to run the job, I will move it back in the job queue to the timeout, so that first that the other workers don't see it at the moment, because they should not try to log or try to work on the job which is already logged and someone works on. And if we fail here, if we don't go back to it, if we don't unlock it, then someone else can come and fix it up. Okay, all good now? Not really. There's one big problem remaining. Here is Bob again. There was when he needs to roll out the latest security fix, so it should be done at every host now. So he adds a big job group with a lot of jobs for all the hosts, and they are getting now worked on. But there is Alice. She got another change request for another firewall rule. Of course, it should be also done by now. And the problem is, it should be done rather soonish, but it gets longer and longer, and Alice gets a bit grumpy because her jobs, which are supposed to run rather soon, they take longer and longer. So we need some kind of fair scheduling. So I was thinking, how can I do that? I could do some kind of individual job queue by user, or I could have some priority scheme, but it all sounds a bit complicated. And I would like to keep the scheduling rather simple, so that you don't need to have a complete picture and to load a lot of data to know what you should run. What's easily possible is to calculate the lag. If I get a job to run, I can see how much I'm behind in the timetable. So you can just do something when I'm behind, when I'm in an overload situation. So I just added a small overload implementation check here. If I'm over this lag limit, I calculate the lag. If I'm over this limit, I just do some kind of special magic. What do I do there? I first get a log, because it just should just be one of the workers doing that. The others should do work. It's a lot to do. And even I don't delete this lock. I just let it expire because it should not be done all the time with overload handling, just at a regular interval. But what does it? It kind of reorders all the jobs in the recent past of the job queue. Actually, the actual value doesn't matter at that moment. Whenever there is a worker available, he will do some work. It doesn't matter if the schedule time is somewhere in the past or it's just now. But with the order on the time axis, I do some kind of prioritization. And now I have kind of a fair scheduling between the jobs of Alice and the jobs of Bob, which makes Alice happy again. So, for the final conclusion, Redis rocks. Redis served us very well here for this application, and I would say it's generally useful for the stuff which are rather light, kind of where you just need to share a little bit of data or to synchronize a bit, but don't need to do a lot of data, need to move a lot of data. It's useful if you have data with limited lifetime, and it's nice if you can bootstrap it itself, then it's nice to work with. Okay, do you have questions?
How does Redis compare to the alternatives? Is it equivalent to something like RabbitMQ or?
It has some kind of PubSub feature, so you could also do something like that therein, but it's more used for like a remote variable store. Maybe it's a bit more advanced than maybe Memcached.
MongoDB.
I don't know too much MongoDB. It's probably also. I don't know how many operations on the data itself MongoDB allows.
You're using a different part of Redis than I do. I compared Redis to the DB file DB variants, and Redis is exceptionally good in read often, write once. So if you want a tight variable, key value thing like a DB file, you can go to Redis, and if you do a lot of reads, that might be faster for big sets.
Okay. It's also a very common use case for Redis just for caching. Especially this automated data eviction makes it really nice.
Since it's in memory, you have a risk of losing all your data, yeah?
Yes.
So you can't do anything that's too valuable to lose in there, right?
Yes, kind of. There is a possibility to store them on the file.
Okay.
There is like a log file. We don't need the data. We just have this. It's like a database log file, where if the server goes down and it just restarts with the data as before.
Okay.
Or mostly you have several options how much data you want to lose. Yes?
I forget, so I looked into this several years ago. Does it have clustering or some other data integrity helpers? I can't remember if it did.
It has some clustering options, and we did not use it in our project because it's just good enough.
Yeah, no, that's fair enough.
So
Also,
far, what we have is
issues.
like we have a hot standby cluster which just gets something like log shipping if you want. It gets all the changes, and we just could like switch them.
Thanks.
More questions? Okay, and good then.
Thanks.